Now let us look at the principles governing the line of balance. Logic diagram for sequence. What we see is a node with a forward pointing arrow to another node. This is a representation of an operation in a line of balance scheduling method. The first node represents the beginning of the operation, and the second node represents the end. And the end node acts as the beginning for another operation with a forward pointing arrow to another node. That end also begins another operation with an end in between having a forward pointing arrow. This is the logical sequence of operation in line of balance. So we have operation A, operation B, and operation C. The above illustrates the logic diagram for three operations A, B, and C in a construction sequence. Line of balance diagram. Non-parallel working. Now, this is a representation in graphical format of a line of balance diagram. We have a vertical axis and a horizontal axis. The number of units for the project is on the vertical axis, and the duration in terms of time in days, weeks, or months is represented on the horizontal axis. And the bars we see as A, B, C represent operations in sequence. The gap between one operation sequence and the other is called a buffer. And the end of the operation for the entire project would represent the overall duration for that project. Between each operation, there is always a buffer. That is a buffer acting as a period of rest between which the next sequence of operation would commence. Parallel working or ideal relationship. So where the operations are parallel, as we can see, which rarely happens, and that is why it is known as an ideal situation or relationship. We have the buffer at the bottom or on the horizontal axis, or at the bottom of the operation is the same as that at the top of the operation between A and B and C. But when we look at the non-parallel working, the buffers differ. And these buffers are determined based on the rate of flow of work, which we will look at when we solve some examples on the line of balance method of scheduling. The first diagram illustrates a line of balance for varying work rates between operations. As shown, operations B and C are not synchronized with operation A. By increasing the workforce on operations B and C, the revised LOB in the second diagram is achieved, significantly reducing the overall project duration. Buffers have been added at the beginning or end of each operation to introduce flexibility into the schedule. These buffers also ensure that each operation is completed within a unit before the subsequent operation begins, preventing overlap and enhancing workflow continuity. Activity B is slower than activity A. Activity C is also slower than activity B. It is therefore noted that operations B and C are out of balance with operation A. Operations A, B, and C on the other chart, that is the chart with parallel working, are moving at the same rate of construction. To achieve this, you have to increase the number of gangs for activity or operation B and C. Another principle. Let us look at this logic diagram for the sequence. We are presented with another operation and another operation, but this time two arrows originating from one node to another node. And then we have another operation, but this time with one forward pointing arrow. These are four operations, operations A, B, and C, occurring at almost the same time, and operation D. This diagram outlines a construction sequence where operation B and C are scheduled to start or complete at the same time, ahead of the start of operation D. The graphical representation of the line of balance diagram. Operation B and C commencing together. Where operation B and C are commencing together, you have operation A very independent and operation D also quite independent. But operation B and C started from the very same point, but the rate of work for B is faster and will complete earlier than the rate of work of C. So the rate of work of C will complete much later. Now let's look at operations B and C finishing together. Operation A is distinct. It commenced and finished independently. Operation D also started and completed independently. But operation B and C started at different times but completed at the same time. In this case, operation B moved at a slower rate, whereas Operation C moved at a faster rate, but both of them overlapped and completed on the same day. C proceeds at a slower rate than B, and on the other case, C proceeds at a faster rate than B. The first and second diagrams display balance diagrams for two cases based on whether Operation B operates at a slower or faster pace than Operation C.